Hey everyone! In this video we're going to talk about how to design UIs for Macs and Macs for Live devices using the JWeb object and HTML5 canvas. With the JWeb object we have all the extremely cool possibilities of the HTML canvas, which is pretty similar to the JS UI object, but has some advantages. So we can create all sorts of crazy UIs, and this tutorial will see how to create circles springing from the mouse every time the mouse moves inside our Macs for Live device. So this could be the starting point for a series about creating extremely cool GUIs or simply kind of custom mouse pointers, effects, something like that, which definitely will add something to your devices and patches. Cool. So without any further ado, I hope you'll have fun as much as I do. And so let's start. Okay, so as always, let's start from scratch. Let's create a Macs audio effect or a Macs instrument, whatever Macs for Live device type you want to create. You can choose the one you wish. I will go with the audio effect. So I drop it here, then I open it and we'll open the Macs patch. Now, I'm going to create a JWeb object, which is the object we are going to use. And instead of using the URL message, which will allow the JWeb to read a website from the internet, I will send it the read file message, which will allow the object to read a file from our computer. So what I want to read is a file. We can call it cool pointer.html because we need an HTML file. Cool. That's what we're going to need. And then I send it to the JWeb object. So connect it and click on it, but we still don't have any file, so it will not find any file. Now let me save this device. I'm going to save it in the Macs audio effect folder as a cool pointer tutorial.amxd. Save. Cool. And then what I want to do is to show containing project. And now I'm going to add a file to the project because we're going to create this cool pointer HTML.file. So I'm going to click here, add file to project, add new file. So what I'm going to do is to create this file. I will call it cool_pointer.html. And it automatically ordered the file in this other folder. So if we right click now on this file and we say reveal in Finder, you can see that this file is indeed inside documents, Macs 8, Macs for Live devices, cool pointer, tutorial project, and then is in a folder which was automatically created called other. Cool. So we got everything we need. Now what I'm going to do is to right click on this and say open with Visual Studio Code. So it will open a new Visual Studio editor window. You can use the editor you wish. I'm just using Visual Studio Code because it's the one I prefer, but you can definitely use whatever editor you like. For example, like Sublime or something else, or Beam even. So now that we got that, I'm going to put them one next to each other, these two windows. So we have a nice working layout. Cool. And okay, so now we need to create some HTML that the JWeb object can read. And then in this HTML, we are going to add also a script for our animation. So what we can do to make this a bit faster, instead of creating all the HTML code from scratch, we can start to type, and this works as well in Sublime as in Visual Studio Code. We can start to type HTML, and I will choose HTML5. And I click on this, and we create this boilerplate code, which is really cool. Because now we already have something to work with. So if I now click here on the read file message, you can see that the JWeb is actually reading this file and is visualizing it. Let's try, for example, to add a simple paragraph. So let's write a paragraph here. Hey, ciao, save it. And as you can see, it appears here. So now we have the confirmation that is reading our HTML file. Very cool. We actually don't need this compatible thing. We can leave the viewport as it is. Although we don't really need that. We can actually delete that as well. We don't really need a title, but sure, why not? So we can call it cool pointer So all this stuff goes in the head tag, which contains stuff that we don't see in the page. So what we see is what is inside the body tag. So we write here our paragraph, and we're also going to create inside here our canvas tag, which will contain the canvas on which we render our stuff. So what we can do now is to start creating our script, because this is actually what we really care about. So the script tag will contain our JavaScript script, which will allow us to render whatever we want to with the canvas. Cool. So basically, from now on, you could just drop this tutorial and start watching some tutorials on HTML5 Canvas, because we are going to use Canvas as you will find it in all the other resources in the internet. There's nothing which is particular to Max, apart a couple of messages. But apart from that, everything else is basically the standard HTML Canvas JavaScript code. So you could learn that in a lot of different places, but I'm sure you prefer to learn that from your friendly, amazing Max Stuff Federico guy. So what we need to do, first thing, is to create a const. Oh, and we are now in JavaScript ES 7 or 6, not sure. Anyway, it's not the same JavaScript that we have when we work in the JS object. It's actually the same JavaScript that we have when we work with the Node.js object, Node script. Okay, so it's the latest version of JavaScript. And in the latest version of JavaScript, we have a couple of different things. Instead of using var for everything, which will just create a variable that is in the global scope, we will create variables using let and const. So you can check on a lot of resources what those type of variables do, but in short, let will create a variable that can only be used in this scope. So if we create a variable let inside a function, it will only exist inside that function. So this chow here only exists inside the scope of this function. And const is exactly the same as let, but it's a constant variable, which means we cannot modify it once we have created it. So we're going to use const to create a canvas variable, which we're not going to modify anyway, we're just going to use it. So we have to do like this: document, query selector, and query selector means that we can now select an element from our HTML code. And in fact, I'm referring to the canvas element. So the query selector will look for all the element in our HTML code as we write here, so canvas, and will give us the same element as a JavaScript object. So it will give us the document object, which will have all the properties and methods that we are interested in. So in this way, we get possession of the canvas. Cool. And then what we want to do is to, for example, resize this canvas to the size of our window. Actually, the max window that you see here, the JWeb window that you see here. So to do that, we can do that like this. We can set the width of the canvas to a built-in variable in the window. The window is basically the browser window that we see here. And in our case, the JWeb window. This has this inner width property. And actually, when we want to access properties of window, we don't really have to reference window. We can just say inner width, and the browser will know that we are talking about the window inner width. Okay. And then for canvas.height, we can use the inner height. Okay. So now if I refresh here by clicking there, you can see that it actually has created those scroll bars, which I don't like to have. I don't like very much to have the scroll bars. So if we want to get rid of them, we have to style a bit our body, because this is all happening in the body, right? So we need to say we need to add some CSS for the body that will eliminate the scroll bars, and we can do that like that. In our head tag, we can create another tag, which is called style. And inside this style, we can write some CSS. Actually, we should first write type equal text CSS. So it knows we're going to write some CSS, I guess. And we want to modify the body tag. So all the body tags will now be styled according to what we write inside this body CSS style. So we can say, in order to get rid of the scroll bars, we can say overflow columns hidden. And now if we refresh this here, as you can see, the scroll bars disappeared. Very cool. We could even set a background for our canvas. So if you want to style the canvas element, we can set a background from here. Now, if you want to have a transparent background for our JWeb object, we should not set the background from here, but just for to show you how this works, I will do it. So we can write, for example, blue. And then if I read it, you can see that now the canvas is a blue color. But as you can see, we still have this white border here on the left, which is on top, which is not really nice. So what we want to do to correct that is to go in the body, styling, and write margin 0. This should do it. Yes. So now we set the margin 0 because the body by default has some margin from the edges of the window. And in this way we get rid of it. Okay, nice. So now we are ready to work with our script. Let's go back here. And if we want to do animation in the canvas, we have to do it in a very special way. We have to create a function and call it, for example, animate. We can call it whatever. Or we can call it actually loop or something. Loop. And inside here, we have to call another function, which is a request animation frame, which is again a property of the window object. So we say we don't need to specify that this is a property of window. So we can just call it like that. And as an argument to this function, we give it the name of the same function that we just created. So what happens is that when we call the loop function, it will call the request animation frame with the loop function, which means it will keep on calling itself until we actually close the program or destroy the JWeb object, or we stop it in some other way. But this is what it's going to do. So this is like an infinite loop. Let's actually write it. That is going to happen at a certain frame rate, which we could also specify. But I still haven't checked out to actually. Doesn't matter. It's going to be by default 30 frames per second. I will show you. Now inside here, we can call whatever we want in order to draw stuff on the canvas. First of all, I'm going to show you how we can output messages to Max. And we can do like this, window, so again, a property of Windows, but this is just something that works in Max. So we actually could avoid writing window and just write max.outlet. And this is only something that works in Max, not something that you will find in a Safari browser, right? This is only something that works in the JWeb object. So in this way, we will have a bang output from the outlet of JWeb at each frame. So if we try to do something like this, use a jitter FPS GUI to check the frame rate and reload it to load the latest version of our file, you will see that nothing is happening, and maybe you already know why. Basically, it's because we never called the loop function, we just declared it. So if I want to call it, I can put it after that, so at the end of the JavaScript file. And now if I refresh, we should see some frames happening here. Okay, very nice. So this means that it's continuously calling the loop function over and over. Now, if I click on the JWeb object and I go here, you can see in the inspector, you can see that it has an attribute which is called render mode. Now, if we choose on screen, the refresh rate will be much higher, will actually be the maximum refresh rate possible. But if we choose on off screen, then it's going to be much slower and use more resources. So that's one trade-off. If we want to use it with other Max objects, we have to use it necessarily with off-screen, because on-screen it's just going to put it on top of every other Max object, but it's probably going to use the GPU, I think. That's why it's so much faster. But since we want to use it as a UI for a Max for Life device, it's not gonna do us any good. We need to use it as off-screen, because in this way it's going to use the CPU, I think, and we can place it below other Max objects, okay? So that's the catch of the JWeb object, but it's all good, it's not too bad really. So cool, now let's see how we can create particles every time the mouse goes on top of the JWeb object. And we can do like this. So I want to create a class of particles, and every time the mouse moves inside the window, we will add some particles to an array of particles, and they will be shown at the mouse position, and then they will start to move randomly. So let's create these class particles. I will do it using the old ES5 syntax because this is the one I'm more familiar with, but we could also do it using the more fancy new ES6, ES7 syntax, but we will do that probably maybe in the next time when I will have checked that out. So as a constructor for our class, we want to have the x position of the particle, the y position, and a radius. So we want to pass that to some properties of this object. So this x is going to be equal to x, this dot y is going to be equal to y, and this dot radius is going to be equal to radius. Nice. And then we want to have a couple of functions. One is going to be update, I think, where we're going to update the position and the lifetime of the particles, and the other is going to be draw, where we actually draw the particles. So in order to draw something in our canvas, actually we need another object, which is the context object. So let's create a new constant and call it context. This we can get from canvas, so canvas.getContext. And then which context we want. We want a 2D context, because I guess there is also a 3D context. But we want a 2D one, so we will say getContext2D. So this is very similar to the JSUE object when we say that we want to use a canvas inside it. In the same way, here we're going to require the context from the canvas. And now with the context, we can use it to draw. For example, if we want to draw a circle, we have to say context. We have to first call the begin path function. Now the begin path function will start a new path, which is made of more subpaths, and a path will basically connect together several shapes that we draw inside it. So if we would have like multiple lines and in the same path, they will all be connected. In this case, we are just going to use it to create circles. So if we want to create a circle, we have to say context.arc. Arc is the function for the circle. The first argument, as you can see here, it even suggests us, is the x position, and this is in pixel. Note that this is in pixels. It's not like in an OpenGL world where it goes between -1 and 1. This is actually in pixels. So for the y, the same. We will choose maybe an y position of 200 pixels. Then a radius, we can check at 100 pixels. Start angle is going to be 0 for us, and the end angle is actually in radians. So being in radians, we can use the math.pi, the built-in JavaScript math library pi constant multiplied by 2, so it will give us a complete circle. And then the last argument is just a boolean, which means which asks us if we want to draw this arc in clockwise or anti-clockwise. We just don't care, so we would set it clockwise with false. Okay, cool. So now we have almost everything, because now if I try to render a circle, as you can see, it will not work, because we still need to call another function from context, which is the fill function. So now it knows that it needs to draw this circle. And we have a big black circle. What if we want to color it? Well, we can do it very nicely by setting a property of the context, which is called fill style. And we can say, we can choose here a color. Note that this must be now in quotes, not like when we were using the CSS where this was not in quotes, was not a string, because this was CSS. But inside here we are in JavaScript, so I had to put this inside quotes. Now if I reload that, we get a red circle. Okay, cool. Let's try to move this circle from x from left to right. So let me create a variable for the x. I will actually create it outside of the function, so it's going to be global variable. I'm going to use it here, and once we have drawn it, I'm going to add a pixel to the x for each frame. So as you can see, it's now drawing our circle from left to right, but it's not erasing the background at each frame. And this is why we see the trail left by the circle, right? This is like when we have JIT world and we set the erase color alpha to 0, and this was actually working in GL2. then we will have the background keeping on adding on what was already being drawn the previous frame. Now this is not necessarily what we want, so we can say gtx.clear rect in order to fix that. And I actually forgot to add some variables, so we need to specify which rect is that. And the rect is going to cover our whole canvas, so we have to say it goes from 0, 0 to inner width and inner height, so the size of our window, basically. Cool. So now, as you can see, is refreshing the background at each frame, so we can see the circle traveling without having the without leaving trails. Nice. Okay, so let's delete that, and let's delete that, and let's actually cut that. We're going to put that inside our drawing function of the particle class. So I'm just copy that here. And instead of using x and y, we're going to use this x, this y. The radius is going to be our this radius, and the rest can be all the same. Fill style, for the moment, we're going to leave it red. Okay, so another thing that we want to add here is an initial velocity for the particle. So every time a particle is created, it will have an initial random velocity. So we can make this an array. And we can say math random minus 0.5. So math random will create random numbers between 0 and 1. Minus 0.5 will create random numbers that go between 0.5 and minus 0.5. And then we can multiply this by 2, so they will now go between minus 1 and 1. So this will be the x random velocity. Let's copy that, and this will be the y random velocity. Let's actually put it in a new line. And then what we need to do every time we update is to say this position, no, this x is plus equal to this velocity 0, right? And this y plus equal this velocity 1. This will give us moving particles as soon as they are created if we call this update function. Okay, but we are getting a bit ahead of ourselves here. Let's actually just start adding particles. And we will do that inside a function which will check every time the mouse is on the canvas. We can call this function from window, which is window.addEventListener. So we can, in JavaScript in the browser, we can add event listener to whatever objects inside the HTML, basically. And with that, we are going to add an event listener to the window. So everything that happens to the window, it's going to be reported. And there is a bunch of things we can report. For example, we can report every time the mouse moves on the window. So we can say every time the mouse moves on the window, call a function, and we could write a function here and then use it as the argument of this function. So like this, let create particles, and this we can make it equal to a function, which takes automatically as an argument the event. And the event is an object that has some properties, and then we could use it like this, create particles. Or we could just use an anonymous function as the argument, as the second argument to the event listener, and do like this function event, and then write the function directly inside here, as we declare it as an argument for that function. This is just something neat that JavaScript lets us do in order to spare a bit of variables creation, I guess. Okay, so let's do like this. And we can say, basically the x is going to be the event.x. This is going to be the mouse position, and y is going to be the event.y. We can now create a particle every time the mouse moves. Actually, before we do that, let's create an array of particles. We are going to declare it here before we declare our loop function. And let's call it simply particles array. It's going to be an empty array. And every time we move the mouse, we can say particles array.push new particle. And our new particle wants an x and an epsilon and a radius. So the radius we're going just to create it as a random value. So we can use again math.random multiplied by 5, per example, with a minimum radius of 2. And then we can use it here. Okay, cool. Now if I do this, nothing will happen because it's actually adding the particles, but it's not drawing them, right? So we have to find a way to draw these particles. So inside our loop function here, which is where the action happens, we can say for every particle inside the particles array, you call the update function and call the draw function. So let's do it. For let I equal 0, I minus then particle array dot length, I plus plus. So we iterate through all the particles. We want to say particles array I dot update and particles array I dot draw. Okay, so what's gonna happen is that it should actually create some particles, update them, so move them around and then draw them. Let's see if this works. And of course it doesn't work, and we can see that there is an error in our code because the FPS here is not being updated anymore. But unfortunately, differently from the JavaScript object inside the max, which gives us the post function, which we can use to post stuff to the console, we don't have this luxury inside JWeb for the moment. So we don't know exactly what's the problem. It will not tell us in any way, we just know because it stopped working, right? So that's a bit annoying. So we need to go in all our code and check if we can see something that is clearly wrong. And we can start, for example, to comment things out to see if then it will start at least to run the FPSs. Okay, it stops as soon the mouse is inside the canvas. So we either do something wrong here when we use the event listener, or it's something wrong inside our particle class. So let's try simply to not push particles inside it when we move our mouse and see, okay, so the problem arises when we add some particles inside this array. Oh god, people, you know what is the problem? It's actually really silly. I forgot that we are inside a class here. So this should be this update equal function and not function equal this update, because this update is now a property of this class, of this object. So yeah, super dumb. This cost me quite some time, I have to admit. But that's also because kind of in the JWeb object, we don't really have a way to print stuff out. It doesn't give us errors. So this would have made it solvable in 1 second if we had some kind of error report from the JWeb, but it doesn't matter. Now it should be all good, so let's give it a try. All right, you can see that particles are being created and they are generated every time the mouse moves. Now, the problem with that is just that they are continuously being increased. The number of particles is continuously being increased, right? So at a certain point, we will just have so many particles that our patch will stop working, probably. So what we want to do is to give those particles a lifetime and let them perish after a certain amount of time. So let's create a lifetime property for the particles and give it an initial amount of 1. And at every frame we want to say this lifetime minus equals 0.05 or something. Yeah, something like that. So at each frame we will subtract 0.05 from the lifetime. And then if this lifetime is less or equal than 0, we want to say that this is dead equal true. Now, this is dead is going to be a Boolean variable that we are going to assign to this class, Boolean property. So this is dead equal false by default. So before calling the function, we can say if particles array I dot is dead. If this is true, then we want to say particles array dot splice, which means remove this element from this array at this index, the index I, and how many elements we want to remove? 1. So we're going to say remove the element at this index in the array and 1 element. So If it's not dead, then we can simply update and draw. So let's take a look. Let's see if all works. And yes, it seems to be working, and after a while our particles are disappearing because their time is up. We could increase or decrease this number if we want a longer lifetime or a shorter. For the moment it seems to be about right. So just what I don't like is that they stay the same size from their birth to their death. And we want to change that. So we could do like this. We could multiply this radius by this lifetime, which means the radius is going to be first. Oh, and we get some weird glitch. Oh, and I think I know why. It's because the lifetime is going below 0 sometimes before the particles stop drawing. So this is unfortunate. So we can do like this. Let's create a new variable and call it radius, which is going to be equal to this radius multiplied by this lifetime. But we're going to take the math.maximum between this value and 0. So it can never go below 0. So let's use it now here, and let's see if now we get a glitch. No, it's all good. And as you can see, the particles are first big, and then we get smaller and disappear. So that's pretty cool. We can actually make them a bit bigger. So when we create them with a random radius, we can maybe have the radius a bit bigger. All right, or maybe you know what? We can actually create more of them. So what we can do is to create here a for loop. So for let I equals 0, I less than, and this depends how many particles we want to create at each frame. Let's say 10, I plus plus. We're going to do that. We're going to get a different radius for each particle, and we're going to create 10 of them for each times the mouse moves. So we're going to have now a lot of particles. I really like how they disappear then in these little bubbles. Now we could have also some different colors for the particles. At the moment it's just red. I really want to have them a bit bigger though. So let's try to have them with a minimum radius of 10. This could be a bit too much. Maybe I want them to live longer actually. So let's make the lifetime reduction a bit less. So now they live a bit longer. Okay, this is pretty cool. Now I want to show you something. If we go here and we set the off-screen with the render mode to off-screen with transparent background, we should be able to use these simply as a background for our device. The problem is that at the moment we have a background for our canvas, so we can just comment that out. And nice, now we can see that the background is disappeared, and we can use that simply as a background for our device. So I'm going to add it to the presentation. Going to presentation mode, we are going to add it inside our device view, which is going to be something like this, I guess. Yeah. So if we close this device and check it on Ableton, and we should of course open it in presentation, my bad. So we go here in the inspector of the patcher and we say open in presentation by default. Right, close it, and now we have the presentation, and nice. We have our particles being created every time the mouse is on the JWeb object. I think I didn't put it all the way to the left. So there we go. And now we got it. We could also add some Max GUI objects here and then have them on top of our canvas. Unfortunately, they cannot be on top of GUI objects, but I think that's fair enough. Now, just about the color, I'm not completely satisfied. I would like to have them a bit more colorful. So what we can do is to go into this website, https coloradobe.com. And here we have a lot of ways to search for nice colors. For example, we can go into the Explore tab here and explore according to some mood or some keywords. So for example, I want to have something that makes me think about a forest. So it will give us some green palettes. Let's take this one, for example. Cool. And we could copy all these colors individually, but what I'm going to do is I'm going to copy that as a CSS. Going to go here, and inside our particles class, what I want to do is to basically copy all this. It's going to contain a lot of stuff, unuseful stuff. I'm going to delete all of that. I want to be left with these colors here. And there is this cool thing we can do with Visual Studio Code, which allows us just to copy that stuff, copy the colors, cut it, and then delete all the junk. And then I want to create a new variable and call it these colors. And it's going to be an array where I copy all these colors. This must actually be encased in strings. So we put a string, we put them all in strings. Put a semicolon here at the end, nice. So we could say, instead of having our field style to red, we could create a new variable actually, call it this color. So let's actually call this color palette. And then this color is going to be equal to this colors palette. And we're going to choose a random index from here. So we can say mat random, which creates a number between 0 and 1. Multiplied by this color palette dot length. Since we need an integer number for the index, we are going to use math.floor to get the smallest integer from the float number that we get with this multiplication. And now we can use this color instead of the red hard-coded here. Cool. So let's try now to load the file again, and cool. And cool, as you can see, this is working. Let me delete that. Ah, there is something I forgot, and that's why the canvas is only arriving till here, which is every time we resize our window, we want the canvas actually to follow the size, the new size of our JWeb object. So in order to do that, we can add another event listener. So we can say window, although we don't have to say window, but okay, we can say window resize. And sometimes you see I'm using this single quote, sometimes double quote. It doesn't really matter at all, apart from some cases in which you want to use quotes inside a string. So we're going to use anonymous function again. And we're going to simply copy those lines, canvas.width equal inner width and canvas.height equal inner height. So every time we resize the JWeb object, now the canvas is going to expand it to its full length. That's pretty nice. One thing I'm still not super satisfied with, and that's the last thing, is that the particles start already big and then they disappear very small, but I don't like so much that they appear already so big. I would like them to kind of appear small and then get big and then get small again and disappear. So in order to do that, we can use a little trigonometry. Instead of multiplying this radius by this lifetime, we can take the math.sine of this lifetime multiplied by math.pi. So it will go between 0 and 1 and then go back to 0. According to the lifetime, and I multiply this by the radius. I think this should work. Not sure though. Let's give it a go. And yes, this seems to work. So they start small, then they get big, and then disappear again as small particles. And nice, we now have a super cool pointer with particles following our mouse. So this was it. I hope you liked the video. I want to do more videos like this on JWeb and GUI design. This is something that I find extremely fun to work with. And if you want to get the patch, you can download it together with the JavaScript code and HTML from my Patreon for a little fee. If you subscribe to the Patreon, you will also support the channel and get access to tons of jitter patches. And also to my Discord community, which is pretty massive nowadays. And anyway, I hope to see you in the next video. Have fun. Ciao.